taking a look at some of the rest of our heat adaptations. And one of the things you're going to notice on a lot of these is they are quite similar to a lot of the adaptations we saw in response to exercise. And again, this is because these two things do kind of cross-acclimate. Being in the heat will get you better at endurance activity and vice versa. Again, the combination of them together is actually quite a strong stressor to increase some of those exercise characteristics that we had talked about. So one of the things we're going to see is after spending time in the temperature, you will see a decrease in heart rate, which is going to mean the heart is going to work less at a given level of strain. You can see this here with somebody that's been acclimated to heat exercising. So this isn't with exercise training, but actually with just heat training, and then you put them into a stress response that would generally cause an increase in heart rate. You see those folks that have been acclimated to heat have a lower heart rate in response to an exercise stressor relative to those that have been unacclimated. The other thing we're going to see is at any particular core temp, there's less of an increase in core temperature for a given temp stressor, which again is going to decrease our likelihood of hyperthermia. You can kind of see this again here over particular stressors in increasing amounts. As you can see, 1, 2, 3, and 4 along the bottom. Those folks that have been unacclimated have a higher core temp increase relative to those that have been acclimated to heat. So again, less thermal strain due to that. We know we have increased plasma volume, and we've talked about this a little bit with exercise. It is one of the other things you see with heat training as well. We end up getting increased plasma volume, mainly because we're trying to conserve those liquids with aldosterone sensitivity, ADH sensitivity, and a number of things like that. Because of that, we can maintain a better blood pressure, due to have a little bit more blood volume. And again, this is partly due to the sodium reabsorption and the water reabsorption at the kidneys. Again, these pathways that we've talked about here, that increased sensitivity to aldosterone, decreases in GFR, increased sensitivity to ADH. The circulatory adaptations we're going to see definitely very similar to exercise here. Cardiovascular system, we're going to have a decrease in heart rate and increases in stroke volume due to this heat acclimation. We can see this on the graph right here, lower heart rate because of that increased cardiac output. Those increases in stroke volume are really due to those plasma volume increases with more blood being returned to the heart. Again, more blood getting through that heart, and we are able to vasodilate the cutaneous vasculature due to this. The other thing is we do have that hemodilution going on with that increased plasma volume. It's an increase in plasma, not in overall blood. So because of that, there is less viscosity, which means blood flow has less resistance, is able to move through those vessels better because of that. Over time, this plasma volume will get back to its original value, and over time in the heat. But the main thing we can see here, change in plasma volume. This graph is basically showing that increases in plasma volume will lower heart rate. So this is percent increase in plasma volume relative to change in heart rate, and you can see a negative percentage in heart rate as plasma volume increases. So heart has to work less hard as we get more plasma volume in the heat. And again, overall, because we are reabsorbing a lot of stuff here, we are going to have overall more body water. We're reabsorbing more water from the kidneys. We're reabsorbing more salt, which is going to pull more water with it. This is really decreasing the chances that we are going to be as dehydrated, and increases the ability, as we were talking about in the first ones here, to sweat at a higher rate. And again, this hemodilution helps with that heat transfer. We are having this blood flowing more freely, which allows us to convectively cool more. So that is also going to be helpful. Those increases in the plasma volume also allow an increase in vasodilation at the skin at any particular core temperature, a greater increase, which again, more vasodilation means more convective, more radiative cooling, and if you're sweating, more evaporative cooling at that particular temperature. So, and again, you can kind of see this on the graph here. This is looking at forearm blood flow, kind of pre-training, post-training, and post-acclimation. But the main thing you see post-acclimation, higher blood flow to that area, post-acclimation at lower temps. Again, better cooling convectively, radiatively, as well as evaporatively if we are sweating at that point. It also makes that diastolic blood pressure a little bit lower because we have vasodilating this cutaneous vasculature, and because we have that plasma volume, we're able to keep our blood pressures within that normal volume. So again, increased stroke volume, decreasing heart rate means less cardiovascular strain after you've acclimated to these hot conditions. Like I said before, very, very similar to what was going on with exercise. These are almost identical types of changes to that cardiovascular system. But again, this is in response to heat. We will also have some different metabolic adaptations taking place. Again, a lot of these very similar to, because we are having these cardiovascular changes, it is going to change what we are doing metabolically in terms of oxygen supply or not. But the main thing is we are able to supply oxygen better because we have more efficient blood flow. Because of that, the metabolic kind of change we have to do, we're going to be able to do less anaerobic, burn less high kind of cost fuel like that glycogen at these lower workloads. We're going to be able to start conserving that stuff again. So we see a decrease in the contribution of the anaerobic metabolism and an increase in aerobic for any particular workload. So this is the graph we saw before in the heat where things were going this way. In general, what we're going to see on this one is they're actually going to be traveling the opposite direction. So heat adaptation generally reverses that acute response to heat stress. So we are seeing less dependence on the overall metabolic rate at these temperatures. We're not going to have as high a metabolic rate, and that aerobic contribution tends to be much higher after we've acclimated to the heat relative to the anaerobic contribution, which we saw going up in those acute heat responses. So we basically reversed the acute heat response after spending some time in the heat. And again, some of this is due to less sympathetic stimulation, less stimulation due to the thyroid gland. When we're lowering this metabolic rate, we are able to conserve more carbohydrates, so that's the CHO on this one, and increase fats, which again is allowing us to be more efficient use of fuel because we're again able to deliver a little bit more oxygen at this point. And the fact we can do that means we have less lactate buildup, which is also going to increase our ability in the heat. Really, after adapting to this, we are going to get closer and closer to those levels of the VO2 max at normal thermic levels. Because we were saying before, acute heat stress will definitely lower VO2 max. After heat training and after heat exposure, we are going to get closer and closer to those norm levels that we saw when we're not in the heat. One of the things, if we don't have enough water, obviously that is not going to play effective hypohydration, like it says here, in thermal stress is not affected by adaptation heat. So if you're dehydrated, the fact that you've been exposed to the heat is not going to help you in that case. So one of the last things I want to talk about is also this idea of heat shock proteins. This is a metabolic protein usually made in response to biologic stress, so high heat, high pressure, toxic compounds. These are protein folding chaperones, which folding of enzymes, and we know proteins, if they're not folded correctly, they are non-functional. We want to make sure that these get done right. Sometimes misfolding can be deadly. What we're going to see is in response to this, we can get increasing levels of these heat shock proteins. This kind of shows what they're doing here. Being a folding chaperone, making sure that this thing doesn't misfold due to those changes in the environmental temp. Without chaperones, you can misfold a protein, have a disease, have enzymes that are not working as correctly. These folding chaperones, these heat shock proteins are going to help with that. One of the things that we will see in response to exposure to the heat is you are going to get an increase in these heat shock proteins, which are also going to help make sure the enzymes and other things that you're making for your metabolism are functioning correctly and are not having issues with protein misfolding. So overall, if we go and look at a lot of this, we've talked about a number of adaptations. So those decreases in heart rate, increases in plasma levels, those are within a week. So 3 to 6 days of this heat exposure of 2 to 4 hours a day is going to get you enough to get that happening. We will start seeing decreases in the salt concentration after about 5 to 10 days, and changes in sweat rates and cutaneous vasodilation are on the tail end of this time course in that second week. But the main thing on almost all these ones that you can see is within about the first 2 weeks, you are going to have a lot of these adaptations, which are going to make your response to these heat stressors much better. So I believe this is the last slide on this one here. So what we'll be doing in the last little part here is now talking about training and these heat adaptations. So if we bring exercise back into it again, what are some adaptations or what are some changes that we're going to see here that end up being important to us? So I will see you again next time.